Good morning students and welcome to the third video class of chapter Light. In this video, we are going to talk about an application of rectilinear propagation of light, that is, pinhole camera. We will learn about the construction and working of a pinhole camera. Then, we will talk about the characteristics of image formed by pinhole camera. The factors affecting the size of image will also be discussed. At last, we will learn about the advantages and disadvantages of a pinhole camera. Children, pinhole camera is a very simple device and it works on the principle of rectilinear propagation of light. There is a figure of pinhole camera that shows an image of pencil.
Formed by a pinhole camera is inverted and smaller in size when compared to the original object. Pinhole cameras are cheap and simple to make. Let's learn how to make a pinhole camera. Take two rectangular boxes that fit into one another without leaving any gap. Make a small hole in the larger box at the center. On the opposite side of the small box, cut from the middle a square of about 5 to 6 centimeters. Cover this opening with tracing paper. Finally, slide the smaller box into the larger box, ensuring that the pinhole and the tracing paper are in line with one another. Keep a lighted candle at a distance of 50 centimeters from pinhole camera. Now, look at the candle through the hole of pinhole camera. You can see the inverted image of a candle on the screen of the camera. Slide the smaller box to adjust the focus so that you can capture the clear image of a candle. Now, let us see what are observations of the image formed in the pinhole camera. Number 1. Image of a candle formed is diminished in size. Number 2. Image of a candle formed is inverted. Number 3. Image of a candle formed has color. Let us see how image was formed. A light ray from top of candle A falls on the tracing paper at A1. After passing through the pinhole O, a ray from the bottom of candle B falls on B1. Similarly, rays from the candle fall on the tracing paper after passing through the pinhole. Together, these points of light make up an image of a candle. You can see an inverted image of B1, A1 of a candle.
Let's talk about the characteristics of image formed by a pinhole camera. The image formed by a pinhole camera is real. That means it is actually formed on the screen, inverted, and it is smaller than the size of the object. Now, let us talk about the factors affecting the size of image by a pinhole camera. The size of an image depends on the following two factors. The first factor is the distance of screen, that is the tracing paper over here, from the pinhole. And the second factor is the distance of object, that is the candle in the front of pinhole. First, let us discuss the first factor, that is the effect of distance of screen from the pinhole on the size of image. Children, on increasing the distance of screen, that is the tracing paper from the pinhole, the size of image will also get increased. Whereas on the other hand, now let's talk about the second one, effect of distance of object from the pinhole on the size of image. Children, if the object is moved away from the pinhole, object can be a candle over here. That is, the distance of object from the pinhole is increased, the size of image will decrease. Children, we have learnt that one pinhole can give us an inverted image of object. But what would happen if we make another pinhole near the first pinhole? I hope you will find the answer to this question. Pinhole camera does not require any lens, so it is very easy to make it. With this, we come to the end of our video. I hope you are clear with the pinhole camera and have enjoyed today's video. Thank you, children, and take care.